All right. Welcome to Pomodoro Joe for Friday, March 17th, 2023. Today we're doing LeetCode problem 208, implement the trie. I totally messed that up. 208, implement trie, prefix tree. It's a medium problem. A trie, pronounced trie, so T-R-I-E, pronounced trie, or prefix tree is a tree data structure used to efficiently store and retrieve keys in a data set of strings. There are various applications of this data structure, such as autocomplete and spell checker. Implement the trie class. We have a trie initializer. We have an insert that takes a word as a string. We have a Boolean search, which returns true if the string is in the trie. And we have a starts with string prefix, which returns true if a previously inserted string has the prefix. All right, this seems pretty straightforward. I love tries. Tries are awesome data structures. You can think of a trie as like a multi-linked list or like a tree where each node in the tree represents a character, and it can have up to 26 children, which represents all the other characters that it can lead to. So, or if you have uppercase, lowercase, you represent other types of characters, you could have more than 26 children. So basically, for example, let's say we have a trie that represents, we insert the word there. So first node will be a T, the second node, it will lead to an H, and then that can lead to an E, which leads to an R, which leads to another E. But let's say we also have 3. Well, we have the same T node and the same H node, but then it branches. And one branch leads to an E to spell there, and the other branch leads to an R to spell 3. And finally, we might have something like the, where we already have THERE for there, but now we have THE the and it ends. So we need to actually keep track of where words end, not just the characters of the word itself, but we need to know where a word potentially will end. Okay. So let's see, rather than, we've got to put 25 minutes on the Pomodoro timer. All right, 25 minutes on the timer, and here we go. So instead of actually creating like a whole new node and link class that will keep sort of a multi-branch tree, let's just use dictionaries. Dictionaries are a great way to approximate the same type of connection. So the base dictionary will be our base nodes. So we'll have some, I'll call it data. So we'll have some base data dictionary. And so for every first word, for every first letter in a word, there'll be an entry in our base data here. Now the value of that entry will be another dictionary with keys as the second letter of the word, and their values will be dictionaries which contain keys, which are the third letters, and so on and so forth. It's a little bit confusing. Hopefully as we go through this, it'll make a little bit more sense. But essentially, if you have a word like there, then our first dictionary will have T, and its value, it'll be a dictionary with the character H. Okay, how do I show this? What's a good way to show this? Maybe I'll do this. So that T has a dictionary, and in that dictionary, there is a value or a key, which is H, and it will lead to another dictionary where it has a key E, and so on and so forth. So we'll have like dictionaries all the way down. Okay, hopefully that makes sense. Maybe it doesn't. Let's just see if we can do this. All right, the other thing we'll need is we'll need to know where we've ended a word. So we'll need some type of stop character. So I'll have some end char. And in that case, I'll make it this. Now, this isn't great. Well, this is okay. This is basically the end character of a string in many languages, so hopefully this will work in Python. I've never tried it, but we'll see what happens. Right, now if we insert, well, let's see, we'll need to have our data to start with. And we'll basically need to add new entries into each dictionary until we get to the end of our word. So for a character in our word, all right, if that character is not in our current data, we'll add it. And we'll make it a new empty dictionary. Now we need to move down to that level. So our data now becomes our data at C. So if we already had that level, like if we already had a path that led to this character, we'll just set it here. If we didn't have the path, we'll create a new path to an empty dictionary, and then we'll move down to that level. And then finally at the end, we need to make sure that we have our end character. We need to say that, okay, this word ended here. So our data needs to have an entry for our end character. And it doesn't really matter what the value is here, but since we're using dictionaries as values, we'll just make it an empty dictionary. Okay, so that's our insert. Now our search. How do we do our search? Well, we still need to start with our same base data here. Now we need to look for every character in our dictionaries and keep moving down levels until we either don't find the character, in which case we know that this word is not in our trie, or until we reach the end and we have to make sure that we have the end character at that level. All right, so for a character in our word, so if the character is not in our data, then we can return false. Otherwise, we need to move down to that level. All right, and then at the very end, we only return true if this actually ends the word. For example, if we are looking for the, but we've only previously inserted there, then this won't end the word, or we won't have an end character because we didn't insert the into our trie. So how do we do that? Let's see. I think we just look for this end character in the data at this point. So that should be our search. And last but not least, starts with. Very similar to our search, except in this case, we don't need to end the word. We just have to say, do we have anything that starts with these prefix characters? All right, so we start with our base data here. And for character in our prefix, now if we don't find the character, then we can return false. Otherwise, we need to advance to that level. And if we make it all the way through, then we can return true. Okay, I think this should be it. Let's see if this works. All right, that works. Let's see if we can pass all the tests. And we do, and we actually do pretty well. We pass all the tests and we get a 95% for runtime and an 85% for memory. That's not bad at all. All right, so that is your brief introduction to tries. Tries are amazing. They're super cool. I love them. Check them out. Play around with this one. It's fun. All right, and that is it for me. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write a better trie.